Welcome to Pulsar Summit Asia. Good afternoon for everyone. For this session, Jesse will introduce Pulsar for Kafka person. In this talk, he will cover the key differences and how Pulsar adds new feature that are missing in Kafka. Jesse is a data engineer, creative engineer, and managing director of Big Data Institute. I think if you are familiar with Pulsar, you must know Jesse. Now let's welcome Jesse.
Thank you for that introduction, Jennifer. Thank you everybody for joining me. As she mentioned, this session is called Pulsar for Kafka people. In this session, I'm going to expect that you have a background in Kafka and you're looking to understand just what is different about Pulsar, how is it unique, what are the similarities. So let's go through that. Here's our itinerary for the next 40 minutes. First, we're going to start off by introducing what Pulsar is. What is Pulsar? What is Kafka as well? Then we're going to talk about the architectures and the architectural differences for these. Then we're going to talk about the API and any programming differences, and we'll share some HelloWorld code so that you can take a look at that. And finally, we'll talk about the use cases. This is a really common question that people ask of what are the use cases in which Pulsar is applicable. So let's go ahead and start. To start off with, Pulsar is a distributed event streaming system. This is slightly different than what we're used to maybe with Kafka, where it's more of a messaging system, but it's a distributed event streaming system. And there are some newer features that are part of Kafka that you may not have been used to. And one thing I think that's really different and is unique about Pulsar is that it uses a distributed log. We'll get a little bit deeper into what that distributed log means and what that does, but that distributed log is what's used to store these messages. So instead of the messages being ephemeral, maybe like we're used to with, let's say, a RabbitMQ or something like that, Apache Pulsar stores them all durably. Then we can see that Pulsar was actually created at Yahoo and was open sourced in 2016. It eventually became a top-level project in 2018. A top-level project means that the Apache Foundation voted on it and said, yes, this project is going to continue on and we can continue to use it. Then we have Apache Kafka. So if you're not familiar with Apache Kafka, it would be good for that because we're talking about this as more of a comparative thing. But Kafka is a distributed pub sub system. And that pub sub is really what its core feature is. It's really focused on that pub sub sort of mentality. And we'll get deeper into that in a second. One big difference between Pulsar and Kafka is that it uses a commit log. And that commit log is in partitions. So it's going to store those messages durably, but that commit log is going to keep everything together. It was originally created at LinkedIn, and it was open sourced in 2011, and it became a top-level project in 2012. So now that we've kind of done a brief introduction, let's take a look at the architectures and what are the architectural similarities and differences. So there, just looking at a very basic architecture for Kafka, we see that we have a publisher, and the publisher is not aware of what the status is of its subscribers or its consumers are. This is a very consistent thing. This is a very common thing in these big data projects. And this is a difference from, let's say, an MQ style system where there is knowledge of that, or an RPC where there is a direct knowledge of that. So the publisher, once again, sends its messages, sends its data there into the Kafka cluster. The Kafka cluster is the one that's wholly responsible for everything. And if you're familiar with Kafka, we know that that's broken up into a broker. So within that Kafka cluster, there's a bunch of brokers. So those brokers handle three things. They handle the receipt, the storage, and the sending of that data. So looking over there, we could see our subscriber actually is the one that receives that data that's been sent by the publisher, that producer, but it's all coming through that Kafka cluster. It never directly interacts. The publisher, the producer, never directly interacts with the consumer. And this is an important concept as we design systems that are using Kafka or Pulsar. Now, looking at the Pulsar side, we can see that they're very, very similar, but there's a big nuance here. So let's go through that. So once again, our producers don't send data directly to the consumer. There's Pulsar in the middle. So that Pulsar cluster, that's made up of bookies. brokers, excuse me. So there's those individual brokers, and these brokers are actually stateless. What that means is that you can scale them independently. You can both add new ones and remove ones as you scale down that broker cluster. And so you can do that scaling independently, which is quite nice because of that statelessness. So where does the state actually happen? Well, there we can look down and we can see that we have BookKeeper. So BookKeeper is actually responsible for storing that data. And what's interesting about this is we can also store this and we can scale those independently, because there may be use cases where we have maybe a lot of network traffic, and we can scale those brokers independently. Or let's say we have relatively low traffic, but we want to store a lot of data. Well, we can scale our bookies independently of that. However, with Kafka, we have that one-to-one relationship where we can't scale a broker independently of its storage. Then looking over there at that consumer, we can see that the consumers don't directly respond or don't directly communicate with our producer. All of that communication is done through the Pulsar cluster. So we can see that when we do that producing, we have all that data go through our Pulsar cluster, and it's being stored for us by BookKeeper. Then we have our Kafka partitions. This is a very important concept in Kafka, and I don't think it's well understood in the community, that data, once it's produced, is put into a partition. From there, that data is never moved out from that point. So that partitioning, that data is, once it's in that, doesn't go to a different partition, never moves around. All consumption is done that way. Those partitions are a hard coupling there. So that those actual partitions are there in both a logical and physical division, where they're physically on disk separately and logically chosen at the time of production. In contrast with Kafka's partitions, we have ledgers in Pulsar. And these ledgers actually are how we store data. So we have these topics. Each one of those topics is broken up into its own streams. Then we have that stream broken up into ledgers. And then those ledgers are broken up into smaller pieces as those records. So when we go to store data that's been produced, it is stored in one of those records within one of those ledgers. And then as we add more and more data, then we're able to go through, and if we need, we can allocate more ledgers. And we just allocate more and more ledgers as we need to store more and more data. This nuance, or this difference between partitions and ledgers, may sound like a very small thing, small difference, but it's actually a substantial difference because it allows Pulsar to do some very interesting new things. It allows Pulsar to actually store data, move data, manipulate data in a way that Kafka can't. So then when we look at our Kafka consumers, remember how I was talking about that hard coupling with partitions? So once we have our producers actually put that data into a partition, looking there, when we receive that at our consumer, the consumer is going to receive the data of those partitions. It'll just say, in the case of one consumer, it will receive the data for all three of those partitions. Well, the consumption within Kafka, consumers just receive what has been put into those partitions. There's no logic, there's no extra sauce there. But for the Pulsar side of things, we can actually see that there is a big difference. There's some really interesting features that are part of Pulsar that aren't possible with Kafka. So let's get deeper into that. So you've heard me talk about that difference between segments and ledgers as opposed to partitions. Well, with Pulsar, there is this notion of partitions, definitely. However, we're able to, in Pulsar, actually break out of that partition when we go to do our consumption. So let's go through those three types of consumers that we have there in Pulsar. So we have our failover subscription. Failover subscription is a special type of subscription that says, I'm going to start N number of processes, but I only want one of those to actually receive the data. And that's called a failover subscription. As you can see there on the bottom left, that failover subscription will receive all the data for all the partitions. where we have another process that's kind of waiting in the wings for that failover, for that initial one to die, and then it would take over those partitions. It's kind of a hot spare. Then we have what's called a shared subscription. And what a shared subscription does is it delivers or receives data in a round-robin way. And this is really interesting because we could actually mix and match data. So data could be coming in or have been produced in an orderly fashion, and we could actually break that up into round-robin. And then we have shared subscription, key shared subscription there on the bottom right. In that key shared subscription, what we see is that the messages with the same key will always be routed to that, or consistently be routed to the same consumer. This allows all of the messages, let's say with a key of Jesse, to go right there into that specific place, to that specific consumer, so we could do something perhaps stateful, perhaps stateless on all of the messages. But what we were able to do is say, we know that all of Jesse's messages will go consistently to a single consumer. You can see that there's a minified URL there at the bottom, tiny.bdi.io/broker routing. This is a minified URL that's going to take you to a video I did that goes even deeper into this and what the manifestations are for use cases. But suffice it to say, I'd really encourage you, if you're looking at this and this sounds interesting, go deeper in that video. Now let's talk about our API and our programming side of things. So here's our Kafka producer. This is basically a HelloWorld Kafka producer. We can see the import statements. One of the things that personally I really don't like about Kafka is that it uses the Java util properties for all configuration. We can see that we're instantiating a Java util properties. We're popping in a bunch of configurations. Then we start the Kafka producer. And then although we see the Kafka producer we're putting in a string serializer, there's nothing that is actually schema checking in Kafka. There's nothing that says, hey, one of your producers is sending in ints and you're sending in strings. There isn't that check in Kafka. From there, we create producer records. We send those producer records. Pretty straightforward after that. Now, how does this work in the producer API for Pulsar? Well, we can see this pretty clearly. When we go through and we go to start to instantiate and start to work with Pulsar, we have our Pulsar client, and we use a builder pattern. And in my opinion, a builder pattern is much more straightforward, much easier to debug, to understand. I think there's a lot. It's a significantly better way of doing this. So we use this builder and we say, here's our URL. That URL will point to an initial list of brokers, and then we build that. It gives us our client. Now that gives us our connection into the Pulsar cluster. From that Pulsar cluster, we can then create our producer. So we take that client, we create a new producer. And as you can see, the argument into that producer is to actually create schema initially. And this is something that I think Pulsar really excels at. It says, schema is a first-class citizen. We need to know our schema initially. Then we say our topic, we create that. From there, we use that builder pattern again to create messages, and we send them. So we do that new message, we send our key, here's our value, we send that, and from there we close those sockets. Now on the consumer side on Kafka is a bit verbose. What we have to do is we have to configure our Java util properties again, and then out of that, we have to create our consumer. We have to say, I was receiving a string, or I was sending a string from our producer. Now I'm going to receive a string. Then when we go to do our consumption, we do a consumer.poll, we put a duration in, and then we iterate through that and close that if needed. So I wouldn't say it's the most straightforward API, but it's serviceable for our consumption. Now we compare that to our Pulsar API. Once again, we use that builder pattern just like on the producer side. And what we do is we use that Pulsar client, we build that, and then we have our service URL. From there, we have our topic and our subscription name. So you remember we were talking about those subscriptions before? Well, with those subscriptions, we're able to specify, here's the name of it, here's what type we want. From there, we create our consumer. We say, here's our schema. Well, that schema is actually matched by, Here's what was sent by the producer. And now we actually have schema being a first-class citizen. This is incredibly important for these systems. Sometimes that importance will escape you if you're just starting out with these systems. From there, we choose our topic name, our subscription name, and we subscribe. Then we can do a receipt, and we say, I want to receive a message. And that's a blocking call. That's going to block until we receive a message. From there, we're just going to do a simple system.println, getting the key and value out of that message. One thing that's really different and I would say unique in Pulsar, it's only touched on in this code. We see an acknowledged cumulative. That's a high watermark. That's a way to say, I'm acknowledging this message and all previous ones to it. Well, with Kafka, that's the only way we can do that. We can only do high watermarks, and Pulsar supports those high watermarks too. But now what's really different, what's unique, is you can individually acknowledge messages. You can say, I have consumed this one, didn't consume that one. Also, dead letter queues built in with Pulsar, which is really nice. You also have, and that kind of feeds into that negative acknowledgement. We can negatively acknowledge and say, this one didn't work. I received it, I wasn't able to work with it. Then when we look around into the ecosystem, we can see that there's various ecosystem projects out there. So both these projects have an ecosystem. With Kafka Streams, you have Pulsar functions. We also have KSQLDB for using SQL sort of syntax. However, that is a proprietary product. Although it's Apache licensed in theory, Confluent has put put some limitations on its usage. Then we have Pulsar SQL that is built into the Apache Pulsar project. Then we have Kafka Connect. Kafka Connect is that way of bringing data into and out of Kafka. In a very similar way, we have Pulsar IO that we can take data, put data into Pulsar and take it out. For those of you who are worried about or maybe have some existing Kafka code, there's different ways that you can deal with that. One of those ways is an API compatibility layer, where what you would do is you would take your code, you would take the Pulsar code that is using the Kafka API, you would recompile, redeploy. That's one option. That's a recompilation. That's an actual change of code. Then what's becoming more popular is the ability to use the API level or protocol level compatibility. So that's one possibility. That's Kafka on Pulsar. So that happens where we use the Kafka API. We don't make any changes to our code, but behind the scenes, we're sending all that data into Pulsar, into a Pulsar cluster. And that allows you to not have to change any of your existing code and start using Pulsar behind the scenes. Finally, let's talk about our use cases. In a very basic sense, this is what I tell people when they ask me about, can Pulsar do X? And where X is something that they're doing with Kafka or would like to do with Kafka. And what I like to say is, I think of Pulsar as Kafka++. It is Kafka with all of the features that should have been there. Put a much more blunt way, if you look at the new features that are coming out for Kafka, just take a look. Tiered storage. Guess what? Pulsar already had it. Next one that's coming out, multi-tenancy. Guess what? Pulsar already had it. So what's happening is that the Kafka community is realizing the importance or the features that the Pulsar community has, and they're starting to say, yes, we're going to start doing those features too. So it's in a very basic sense, it's all the things that you can do with Kafka plus more. And what is that plus more? I just wrote a post there that's minified there at tiny.bdi.io/Pulsar CTO. And that's a post that I just wrote and published, and it's called Comparing Kafka and Pulsar from a CTO's point of view, which goes really, really deep into these use cases of when would you choose Pulsar, when would you choose Kafka, why would you do that? And I kind of go through it from more of a CTO's perspective of saying, let's just not look at the tech, let's look at this, let's look at long-term issues. So I would encourage you to read that. One example that is perhaps a good one for you to take a look at is what's called a work queue. If you ever dealt with that or looking at that as a use case, distributed work queues are actually a really bad idea with Kafka. Just to help you understand that, I wrote a post that's minified there as well, tiny.bdi.io/work queues. And in that post, I go through in quite a bit of technical detail of why Kafka is so bad at work queues. And if you don't believe me, there's actually companies who have come out after that and said, yes, this was terrible, or that they said, well, we had to do a lot of workarounds. Workarounds is what you see in a blog post that says we shouldn't have used it. That's kind of what they're saying, or it was the best tool for that we had, or the only tool, or we couldn't do anything else. So do think about that. Work queues, if you're doing work queues, Pulsar is a significantly better way to do this. I would highly encourage you not to use Kafka for a distributed work queue. It's just not a great way of doing that. If you want more info about that, please do take a look at that. Then there's Geo Replication. So what Geo Replication means is if we're going to do a Pulsar cluster for real, for enterprise sort of purposes, we can't have it just in one single data center. And if that data center goes down, it just fails. We can't have that. What we have to have is we have to have the ability for a data center to go down and another data center to have all that data and to be able to pick up that load. Well, here's the issue with Kafka and Pulsar. Pulsar actually has geo replication built in. And we're not just talking about very simple replications of here's a hot and here's a cold. That's a common one. We're talking about all the way up to very complex ones where we're doing actual geo replication, actual active replication. These are non-trivial replications. And so as we can compare that to, let's say, the Kafka side, we can see that the Kafka side isn't as strong. You probably heard of Mirror Maker. Well, Mirror Maker is more of a bolted on solution, if you didn't know that. Mirror Maker is actually consuming just like any other consumer and then sending up to that other cluster. And what you probably don't know is there's a whole bunch of extra operational work and operational overhead that goes into this replication. It's not easy. This sort of replication has to be built in, and being built in with Pulsar, it's much better. It's significantly better. If you didn't know, Confluent has a proprietary Kafka replicator. However, it is not open source and it's quite expensive, I'm told. From there, we get into unified. So what does unification mean? It means to be able to do both MQ style things and pub sub style things. What do I mean by MQ style? I mean queuing, actual queuing use cases. What a queuing use case means is kind of what we were talking about with that work queue of, I'm going to send a message, but I want you to individually acknowledge that. I want to say, you have done this work. Well, that sort of workload isn't possible with Kafka. It isn't possible unless you do a lot of workarounds, and it's a real pain. I would highly advise you not to do that. So what this unified cluster allows us to do is to have a single cluster. What often happens with Kafka when they try to do this MQ style thing is that they will have a Kafka cluster and they will continue to have an MQ cluster, RabbitMQ. We don't want that. What we really want is a unified cluster of doing that pub sub style, that messaging that we need, as well as these MQ style things that we need. As a result of having that single cluster, we're able to cut down our operations costs, infrastructure, operations expenses, all kinds of things. But I would also say from a development and an architectural perspective, having that single place where all the data goes is really beneficial. It's really quite helpful. So take a look at that. If you want this unified system, that is exactly what the unified system means. There's another limitation that you may not know about, and that is Kafka is limited to about 200,000 topics/partitions as of right now. There's been a lot of talk about Kafka saying, hey, we're removing Zookeeper because it's a performance limitation. Well, their usage, their implementation of Kafka is of ZooKeeper is a limitation. But what's really, I think, is pushing them to do this is the scale limitation. If you need millions of topics, Pulsar is the only one that can do that right now. So do really think about that. So I obviously consult around the world. Some of my clients have actually chosen Pulsar specifically because of this part of these, the ability to have so many partitions and topics, because it allowed us to do some really interesting things by getting really granular about our topics. It's really been helpful. So with that, I'd be remiss if I didn't mention my book. I just published a book. It isn't about Pulsar, which I'm sorry, but it's about how to organize your teams. It's called Data Teams. If you want to get more information about it, go to datateams.io. So with that, I'd like to thank you. Thank you so much for spending perhaps your weekend or your late night, depending on where you are in the world with me. And with that, I'll open it up for questions. I have the questions up here right now.
Thank you very much for sharing your thoughts here. Actually, we have several questions from our audience in other platforms. You see that according to your view, it's that Pulsar is equal to Kafka plus. So Pulsar is more advanced than Kafka. When Kafka began to consider a feature Pulsar already has. So we all know that Kafka is more mature than Pulsar, and it was developed earlier than Pulsar. So do you mean that Kafka is out of date and Kafka can be replaced totally with Pulsar?
So the question is Kafka out of date? I think to put it in the way I put it in that CTO post, Kafka has a ways to go on features. I think Pulsar has a ways to go on community. We need Pulsar to get more adoption, more people out there using it. But what I've been told is the basic story behind this is the people who looked at Kafka saw that Kafka was limited on some of these features, that there were some architectural limitations. And so they created Pulsar to deal with those architectural limitations. That was a story I was hoping to tell at some point. But yes, when you take a look at that architecture, you can see that. So personally, I've worked since pretty early on with Kafka. I was one of the, I've been using Kafka for the past 6 years. So I've seen it, and I haven't just seen it. These aren't theoretical things. This isn't theoretically Jesse's opinion. I've actually saw this in the real world, and I thought, okay, Kafka's limited this way. What else is out there? And so personally, when I looked out there and I saw that Kafka and Pulsar did this really well, I thought, oh, okay, I'm gonna start recommending Pulsar to my clients.
Oh, that's great. And another question, does Pulsar has any advantages compared to Kafka?
Does Pulsar have any advantages? Well,
yeah, disadvantages, yeah.
Well, I just went through them in the use case. There's quite a few. If you want to see the advantages, I go through it. When I say in depth, I mean in depth. I think that was 8 pages typed. That Pulsar CTO post. So go through it. I cover it in quite a bit of depth.
So in that post, you have compared both Kafka and Pulsar and list Pulsar's disadvantages. Yeah, do you mean that?
Yes. Yeah, it's a direct comparison. It's kind of me putting my CTO hat on, thinking about it of, if I had a company, if I had to make this choice between the two, here's what I would choose, and not just what I would choose, but why. And then I also broke it down in conservativeness. If you're working at a company that's very conservative, that makes very slow technology adoption, hey, maybe Kafka is the way to do it. But there's actually some things that you can do with Kafka, that Kafka API, that may allow you to say, yeah, we're going to write our code to the Kafka API, but that will give us this ability to move to Pulsar in the future without having to rewrite our code. There's some benefits there.
Yeah, that's great. Thank you. And thank you very much. We also since you are very active in Pulsar community, and most of our audience also watched your webinar on Pulsar, and some of them also participated the training you have shared with them. So I think you are very active in Pulsar community, and thank you very much for your contribution to Pulsar.
Thank you. And thank you, Jennifer. Thank you to everybody. Have a great rest of your day.
Thank you. Bye-bye.
Bye.
Bye.